the CECI is mainly focusing on tier 2, which is basically the computing capacity that you have at your research institution. Okay, and then we have the tier 1 level, which is basically something that is a little bit too big for university, and that is usually provided at the country level or the regional level, and then you have the tier 0, which is the very large scale computing infrastructure. And this talk focus on the tier 1 and tier 0 infrastructure, and how you get access to it as a CC users. So I already talked about that, and the first resource you have, and that you can access with exactly the same account you have for the tier 2, just that you have to apply for a project, is Lucia. So it's made up of two, I would say, main parts. One, which is the CPU part with AMD EPIC Milan CPUs. And then you have a GPU partition where most of the computing power is, that features nodes with NVIDIA A100 GPUs. So Lucia delivered about 2.72 petaflops of sustained HPL impact, which places it in this zone in the top 500, where basically everybody is very close to each other, but basically the last ranking was 322. So it's not exploited by the CÉCI per se. It's operated by CNRO, which is a non-profit research center. And the universities have access to quite a large portion of Lucia, which is 85% of the computer. And if you want to have access to Lucia, you need to basically apply for a project, explaining what you want to do and asking for a source, and then it will be validated and your account will be created. Very fast, so that I am on time. So basically, there is 300 nodes, okay, and out of these 300 nodes, you have 270 standard nodes, which have 256 gigabyte memory, and then you have 30 nodes, which are called medium with 500 gigabyte. And then you have some large memory nodes as well as one extra large memory node available. And each of these compute nodes have 2 EPIC Milan CPU with 64 cores, so 128 cores. Okay, and then where most of the computing power is this 50 nodes with one 30-core CPUs, and then 4 NVIDIA A100 GPUs with 40 GB of memory. And then you have 2 nodes, which are called the AI nodes with 8 A180 gigabyte of memory for the GPUs. What is the role of Lucia? Is that basically it's allow you to run a bigger job than what you can run on the tier 2 machine. If you want to have a full compute nodes, I would say allocated to you, which is of course optimal. If you go to X5, you will probably wait for quite a long time, and if you go to Louvain-la-Neuve 3 or 4, you will wait a little bit less, but still it might be more difficult. But if you need, I would say, to have several nodes allocated to your jobs so that you can run in a reasonable number of time, then Lucia is made for you. So we expect that the job that we run on Lucia is able, at least for the CPU part, to be able to use multiple compute nodes fully. Okay. It's also expected that you have some kind of experience of HPC system before going on an HPC system like Lucia, so that basically you know the basic line, the command line, and as well as how to use them, and also that you have some kind of experience in your group to install the software you need, because the CNRO HPC team is very small. We try to help as the CÉCI, but of course the level of support that you can expect from Lucia is limited compared to what we do for the tier 2 computing, because I mean it's a very small team, so they cannot do everything. So installing software, if they try to keep it minimum, they will not install a big software stack like you have access to for the CÉCI cluster. And also, I mean, we try to help, but we have limited access. We are not good on Lucia. So, of course, we expect you to be able to help yourself a maximum when you access Lucia. And remember also that it's not because you have more resources that you can, I would say, just run big jobs for the sake of it. Yes, there is always this nice zone where your scaling is quite good, but also think that if you ask for a bigger job, then your queuing time will also increase, and then the time to solution may not be ideal. So we skip all of this. With just one announcement, so that for the already existing Lucia users, at the moment, the CPU partition is an exclusive user for the CPU, which means that basically when your job starts, the only jobs that will be allowed to start after that will be one of your jobs, which is good because if you have a job array with small, I would say, resource usage, you can pack this job array on nodes. But CÉCI is thinking about moving to a job exclusive model, which means that basically if you allocate the node, it's just for your job. So you will not be able to start new jobs on that node. So if you are a Lucia user and you do capacity computing with job arrays, it's time to think about changing your workflow. So we already have some resources available in the documentation about the workflow management, as well as we organized a space workshop a few years ago, where you also have the recording available. You can also use nice tools like Hypercube, which is basically a scheduler that will do the scheduling on a subnode level for you. So you have options to prepare for this change that CÉCI will implement, I don't know, in the following months. Now, on top of Lucia, as a Belgian researcher, you have access to an additional resource, which is Lumi. So it's currently the fastest supercomputer in Europe, with a current top ranking, top 500 ranking of 5th. And what interests you as a Belgian user is that it's been acquired by a consortium of 11 countries. The Netherlands joined this, as well as UHPC, more on that later. And Belgium has a 7.6% share of the machine, which means that we are entitled to, I would say, allocate compute time to our user to this machine. And you can see that we go to another scale. It's 248 CPU nodes. I will not go into the detail for the sake of time, but also 2,978 GPU nodes. And these nodes have been touched in the previous talk because it's basically using these MI250X GPUs, which are cheating by presenting them as one GPU, but in fact, it's two. So basically, you can see on this representation that that you clearly see that AMD embraced the chiplet design, where they basically glue together two GPUs to give these very nice numbers. But in fact, when you use them as a user, you need to divide everything by 2 because you will basically use one GCD, which is one of these small part of the picture. So, of course, this is not NVIDIA hardware. This is AMD GPU. So, CUDA is not available because it's a proprietary technology. But AMD provide a similar, I would say, software stack, which include IP, which is the replacement for the CUDA. And the kernel language is very similar. It's only the name of the runtime function that changed most of the time, and you can basically port your code with search and replace, at least for the first step. You can also use portability layers like Cocos, Faja, or Alpaca, and you also have the option to use a SYCL, either using adaptive C++ or Intel data parallel C++. Note that also with this larger scale comes more problem. You may experience, I would say, have a different experience than what you have on Lucia or on the CÉCI cluster on Lumi. We have way more hardware failures because of this size of the machine, but it's improving, I would say, compared to the beginning. So if you were an early adopter, and you get, I would say, upset about Lumi and just giving up on it, I can tell you it has improved now. We have seen also some, I would say, issue with the vendor MPI library. So expecting that your code will run because it runs on another machine is, I would say, not guaranteed. Sometimes we see strange things from these MPI libraries. And also, if you have a workflow with a lot of small files, you can expect your performance to be very, very poor. What we from the file system of Lumi is not really optimized for small files. It's really a bottleneck if you need them. So we run from the tier 2 and tier 1. So already the tier 1 is for bigger jobs, and Lumi is really for very, very large jobs. So if you need tens of nodes on a regular basis, it's good for you. You can go up to 256 nodes at the moment in the CPU partition in terms of job size. And on the GPU partition, you can go up to 512 nodes. You have an option also for a full machine run, but you need to apply for that. We do that on one weekend every month, where the user can apply for a full machine run and run on the full machine, either on the GPU partition or on the CPU partition. To get access, we have regular cutoff dates. And again, it's by project, but you need to basically fill a form where we ask some question about what you want to do. We recommend to start with a preparatory or development project where you basically set up all your workflow and test that everything is running. Getting this kind of project is quite easy. You just have to explain what you are doing and which code you want to use, so that we make sure that, okay, it's compatible with Lumi and you can indeed run. And then once you have everything set up and your benchmark, you can apply for a regular access where you can get up to 5,000 GPU hours or 10 million CPU hours. This number are by design because there is another track to access Lumi, which is via UHPC. And so we are just below what you can ask from UHPC to encourage you as well. And what is UHPC? It's basically an organization in Europe that was set up to, I would say, boost supercomputing in Europe, and they acquired multiple supercomputers recently. So at the moment, we have what they call 5 mid-range supercomputer and 3 pre-exascale, and we have 2 exascale computer planned, as well as 6 quantum computers. So quickly, for the big one, if you want to say prefer to stick with NVIDIA, well, you have an alternative to Lumi, which is either Leonardo with A100 or Marinos 5 with H100 GPUs. So if you want to run very large jobs using NVIDIA GPUs, you have this option. And you have all this range of mid-range machine, which most of the time features NVIDIA in A100. And there is also this Italian machine installed in Portugal, which presents an ARM partition for the CPU. So if you want to experiment with that, it's also available. And regarding the future, so Europe is trying to build its first exascale supercomputer. We are a little bit behind the US in that regard. It started, installation is supposed to start this year. I don't know at which state there. And it will feature 6,000 GPU nodes with GH200 superchip. So GH, if you don't know, is basically the new model of NVIDIA, which is Grace Hopper. So you have a Grace CPU, which is based on ARM cores, okay, used with an Hopper GPU with a fast chip-to-chip and NVLink interconnect, and basically it allows you to have some kind of unified memory between the GPU and CPU. Yeah, for the sake of time, I continue. And also some of, I would say, something special about Jupyter is that also it's the first supercomputer where we try to use the product of what Julio has developed recently. So there is this project which is called the European Processor Initiative, which aims to create an HPC processor for Europe. And basically, Jupyter will have a little bit more than 1,300 nodes with this product, which is the Cyber 1 CPU, which is based on ARM Neoverse cores. Okay, and will also features on the die HBM memory like intended with the Intel Sapphire Rapids. So you add an extra level of memory hierarchy in the mix. So it was very fast. I'm really sorry, but almost on time. So in summary, as a CC user, you really have a lot of resources available to you. For most of you, I would say it's limited to the tier 2 machine. It's enough for you, but we can offer more. So we are either Lucia, if you want to stay in Wallonia, but also at the European level. I mean, we are active, and we you can use up to thousands of GPU if this is what you need. We can also see that what Europe is pushing is that, okay, we want to be a little bit more independent in terms of technologies. So they try to build machines that use European technology, which means that the x86 model might not be, I would say, present any, not as dominant, I would say, in the European supercomputing landscape. And also that we have different model of accelerator that appears compared to what we had before, where it was just NVIDIA that was there. Now AMD also try to compete with NVIDIA. And that's it for me. If there is any question, I can answer them. And the first scientific talk can also.
Sourabi already come down. Maybe we can take one question for Orion. Anyone?
If you don't have question, we are more on time.
Yeah. You want to flee?
No.